Hi, welcome to one and all. Our project title is Increasing the Life of the Spur Gearbox in Rolling Hearth Heating Furnace. The whole project is about increasing the life of the Spur Gearbox in reheating hearth furnace. It mainly deals with the calculating the present life and efficiency of the spur gear and how to improve the life of the spur gear by changing the material of the spur gear. The duty to work, permissible to work, allowable to work, permissible load for strength, axial forces, tangential forces, separating force and other techniques are studied in this project, and the major problem in the heating furnace is that the gear used for tilting the furnace cannot transmit the torque to application of heavy load and hence meets with a failure. The main objective of the project is increasing the life of the spur gearbox in reheating hearth furnace. It mainly deals with the calculating the present life and efficiency of the spur gear and how to improve the life of the spur gear by changing the material of the spur gear. Spur gears are the perfect choice when the need is for producing large motor speed gear reductions in a single step. A single reduction range of 5:1 is considered quite a normal thing for spur gears. It can climb up to 127:1 or even more, under special circumstances. Spur gears are quite in operation. Using a single lead spur along with a 100-tooth gear can do wonders in a single simple step. Actually, by taking a low motor output of 100 rpm, it can give you 1 rpm with 100 times of the torque approximate. These are the factors affecting the spur gear efficiency. They are lead angle of the spur, installation conditions, sliding speed, quality of the surface, choice of lubricant, and then we need to analyze the gears by vibratory loads, or system dynamic loads, depend on the interrelation of the components in the entire system with one another, and toward meter readings for a study of the system is required to assess instantaneous loads. From properly obtained toward meter readings, the load characteristics of the system can be determined, including steady-state loads, peak loads, accelerating loads, reversing and vibratory loads, and other dynamic effects that may exist. Unexpected environmental conditions affecting gear drive performance can be grouped into 3 categories: ambient temperature, either high or low, airborne abrasive material, corrosive materials of gaseous, liquid or solid form gear distress, and failure modes. Distress or failure of gears may be classified into 4 categories. Surface fatigue, pitting, wear, plastic float, breakage. These differences result from the different physical characteristics and properties and from the residual stress characteristics associated with the surface hardened gearing. Mechanical properties of carbon steel: modulus of elasticity or Young's modulus C1 equals E2 equals 42,000 N/mm. 2 in plane shear: modulus G12 equals 188,000 N/mm. 2 Poisson's ratio equals 0.25. Mechanical properties of cast iron: modulus of elasticity E equals 32 E6 N/mm. 2 Poisson's ratio equals 0.35. Density equals 1.65 G/cc. How to mesh the gear teeth part is the key research area during contact analysis of the spur gear. Especially the gear tooth root part is easiest to appear in the stress concentration. For saving the simulation time and ensuring the calculation accuracy, thumb mesh in the region of the contact area is small and thumb mesh in the region apart from the contact area is large. The hexahedron has the higher computation precision than the tetrahedron, so this model applies the hexahedron as the mesh element. However, this model cannot apply the hexahedron naturally. Therefore, gear must be separated along the root circle. The high seed number in the gear contact face and the axis is defined. Element type as 3D stress is assigned at the same time. Since the load is not uniform, we should take the condition that ME2 equals MC to 216.88 kH equals 233.80 kH equals 1.070. The maximum value of kH is 1.070. The gearbox machine assumed to be working 16 hours to 18 hours a day and 300 days a year. For example, 18*300 equals 5,400 hours a year. Cast iron versus carbon steel. The life of the spur gearbox using this material is 2.06 years for medium impact loads or 11,160 hours of medium impact loads. kH equals 1.070. The life of the spur gearbox using this material is 2.082 years for strong impact loads or 11,248 hours of strong impact loads. The life of the Spur gearbox using this material is 6.209 years for medium impact loads or 33,532 hours of medium impact loads. KH equals 1.3 to 1 considering the life of Spur gearbox. We conclude that it is better to opt for carbon steel instead of using carbon steel. The life of the Spur gearbox using this material carbon steel is 6.209 years for medium impact loads or more than 33,532 hours of medium impact loads. The life of the Spur gearbox using this material cast iron is 2.06 years for medium impact loads and the life of the carbon steel is 6.209 years for medium impact loads. Thanks for watching our video patiently.